Hi everyone, welcome to another episode of the Lucas podcast. Today we're going to be speaking about chemical engineering. I'm sure there are many students out there who wish to actually find out more about this exciting course. So today we have with us Dr. Viknesh, we have Aaron, we have Sheng. All right, nice to see you guys here. Right, let's get them introduce themselves first before we go any further. Viknesh?
Yeah, hi everyone. Nice to be here at the podcast again. Looking forward to giving my insights, especially in the area where I applied my trade, which is chemical engineering. So a little bit about myself. I'm Viknesh. I can call me Vic. I'm currently working in an international university in Malaysia as an academic. So I went through the research route and the academic route. So that's one direction I will bring in, and also my experience with students and with the industry as well. So currently I'm teaching in chemical engineering, but my research area is also in a domain related to chemical engineering as well. All right. So yeah, that's me in a nutshell. Maybe I'll pass it over to Aaron. Aaron.
Yeah, okay. My name is Aaron. So a little bit about myself as well. So I've graduated in chemical engineering as same as Vignesh, and now I'm currently working in PMI technology. So basically, we are a manufacturer of industrial equipment. So things like filters, agitators, mixers, pressure vessels, and I'm currently holding a position of sales in the sales department. So that's what I'm doing now. Yeah, I think that's a little bit about myself. Then I think I'll pass it on to Sheng.
Hi guys. My name is Sheng. I'm currently working in the UK in a company called Ceres Power. We manufacture some of the more advanced power generation technologies. We specifically make solid oxide fuel cell. My line of work is involving manufacturing of the fuel cell technologies, specifically looking from the coating and the raw material sides of things.
Hi. All right. Thank you once again for willing to spend your time here for our podcast today. All right. So, thank you, gentlemen, for the nice brief introduction about yourself. So now let's move on and move on to talk about what we are here today. So, chemical engineering. What is it? What is this course all about? Because I always frequently get students asking me this particular question. There's so many different kind of engineering that's actually present out there. And then we have now what we call chemical engineering. The word chemical is related to what I'm actually teaching right now in A levels, which is chemistry. But what is chemical engineering? Could you guys just let our audience know right now what is chemical engineering course all about? Finish?
Well, I think at the end of the day, chemical engineering, right? The main focus for us to pay our attention to it's actually the engineering portion. All right. So the chemical or the chemistry part is something that is constant, but it is the main focus here is engineering. So of course, I think Aaron and Rishan can add on as well. But what chemical engineering essentially is the um, it is the domain or discipline that looks at how we can design processes, operate processes, and at the same time control processes that convert raw material to useful products. And I'm using very generic terms here. Raw materials can be anything that we use as starting points, starting materials, and we can go through a series of processes like in a plant or a factory, all right, or a site, okay, and they go through a set of conversions and they produce a lot of different products. And what kind of products are we talking about? It could be as simple as your soap that you use at home, sanitizers. That's the in thing right now because of the pandemic that we're experiencing at the moment. And it could go as conventional as crude oil. It can also be energy. It can be various other products at the downstream. So this is what chemical engineering is essentially about. The domain. This is what it's all about. But of course, invite Aaron and Sheng to add on as well.
Okay, so yeah, thanks Vignesh. So maybe I can start off a little bit more about what or add on to what Vignesh has said. So for me, if I want to break it down into very simple terms, chemical engineering, please, first of all, do not mix up with chemistry. Okay, so chemical engineers are not chemists. Okay, so as what Vignesh mentioned just now, it is basically the conversion of raw materials into useful products. But adding on to that, we are also actually in the process of translating lab scale or small scale proven processes into actual industrial scale mass production. Okay, so for example, I mean, I would take part of my experience as an example. So making a cup of coffee, right? So making a cup of coffee for one person is simple to do at home. But can you imagine if you want to make it for like 1,000 person, 1,000 people, right? So you can't possibly achieve it by doing it at home, right? So this is where chemical engineering comes in. So the whole process of taking in the green coffees in large volumes, how to put it into unit operations, introducing heat, processes to convert it from green coffee to roast coffee. Then after that, having grinders to break it down and extracting it. All these are part of the chemical engineering process. So for an example, in a coffee production plant, you're talking about a daily production of about 40 tons. Okay, and 40 tons is a huge amount of coffee, instant coffee powder, and that's probably like it can fill probably like 20 million cups. So that is the scale that you're talking about in everyday life. So not just coffee, it could be non-food, it could be like what just Vignesh mentioned, soap, sanitizers, anything else. Okay, and to encapsulate it in such in sort of a technical term, basically we are talking about chemical engineering is also talking about the design and the operation of a production facility by using technology. So that's like heat transfer, energy storage, control engineering, and you want to produce useful products in a safe manner. So for example, in terms of human as well as environment, waste management, that's also a key part of chemical engineering. And the most important part of it is always taking into account the commercial feasibility part, because you can't produce a process or you can't operate a plant that doesn't generate the commercial feasibility, because it's just not going to be a sustainable business moving forward. So that is what I would define chemical engineering as. And from now, I think maybe I can pass on to Sheng. Maybe you have something else to further add on to that.
So in terms of chemical engineering, the things that I want to add on is we are talking about conversion of a raw material to something of a product that people want to buy. How do we do that? We can exploit the chemical properties of chemical properties or the physical property of some of the materials. As Aaron was saying, coffee beans, you have different type of coffee beans. How do you want to process them, or they will react in a different way? So how can we control all those properties is one of the main things that we do. How can we control the processes? How can we control the heat, the temperature, and how would all those raw material respond? Critically is how they respond to all the physical inputs that we put into the processes. So in terms of the engineering, we are looking at the physical or the physics side of things. You want to learn about how the material flow in a tube. You would want to see how the heat will transfer from one surface to the other surface, which will be a huge part of the chemical engineering course. In terms of seeing how things flow, you have liquid, you have solid, you have gas. All three things would react differently in a confined space of a tube or a reactor vessel. So how those three things get mixed together in a reaction, and that is another further topic that you will learn if you choose chemical engineering. So how we would use the physical reaction or the chemical reaction, we can have catalysts that would exploit a lot of the properties of generating some of the products. Even just the water itself, you can split it, because we know water is H2O. You can split the water into hydrogen, you can split it into oxygen. And how would you do that? You would require a catalyst, you would require heat, you would require pressure, and all those has to be encapsulated in a safe environment. And then we are talking about more of the design aspects of things. So we are exploiting the very physical and the chemical properties of all the raw materials.
Yeah, I guess we can encapsulate, or we can kind of consolidate all the things that we've just mentioned. So it is a domain that essentially looks at how we can make things from small scale to large scale. And engineers, especially chemical engineers, get involved in various different things. And I think this is what we're going to explore in today's session as well. So what are the areas where you see chemical engineers working and things like that? So we have just given you a sneak peek, and now I think we will take more questions and to find out what other things that can that a chemical engineer will do, and at the same time what is needed for the course itself. Yeah.
Right. Thanks for the introduction, Viknesh, Aaron, and Sheng. Sounds exciting over there. So it seems like you guys are the main guys, behind all processes that is actually involved out there. Very, very interesting indeed. Okay, so now what about if students are interested to actually take up this particular course, what kind of attributes or what kind of subjects these students need to be strong at PU level, to know that, okay, this chemical engineering is the course for this particular student. So how do we tell what kind of attributes, what kind of subject combination, what kind of subjects that the student must be strong at in order to take up this chemical engineering course?
All right. So maybe I'll take a stab at this first. I think when I mentioned earlier at the start of the podcast, I mentioned that the focus is engineering rather than the chemical, actually. And there's a reason why I mentioned that, because when it comes to engineering, physics is very important. So this is a very important domain of knowledge that we need to be familiar with, right? Some may wonder, actually, is chemical engineering related to chemistry? I think Aaron made a very good point earlier to differentiate the two at the very beginning so that we know your expectations on what chemical engineering is about. So chemical engineering, many people have a misconception that it's a lot to deal with chemistry. But here's the thing, I'm not going to say it's not. It deals with chemistry, but it does not go in depth anymore. So what you've learned in A levels is what you essentially will see in the course, right? But now the engineering portion behind that chemistry comes into the picture. How do we bring it from small scale to large scale? And what Li Sheng mentioned earlier about looking at temperature, pressure, we've learned reactions in chemistry. We've learned how to use catalysts and the impact of catalysts in reactions as well. And in all chemical processing plants, there are reactions as well. So, but then now from the engineering standpoint, how do we make it a reality, So these are the things that are very important. So in terms of courses, chemistry is important, physics is important, but at the same time, that mindset, like this, what I'm going to mention now is more on the skill sets rather. You need to have that passion or the interest to solve problems, because that's a main. I think Aaron and Li Sheng will be, good witnesses to this statement right now. They can vouch for what I'm going to say. Problem solving skills is going to be very important. So this thing is very, very crucial, especially if you're not just taking chemical engineering, any engineering for the matter. Because engineers in general, we are trained to be people that look at a problem and figure out ways to solve. So this is that mindset that we have to have. So if you're looking for what is needed for chemical engineering, that's an essential part. Problem solving skills is very important. So how do we get problem solving skills? There are many ways to get it. You can get it in chemistry, you can get it in physics, you can get it in maths, you can get it in further maths, you can come anywhere. You just need to have that passion of sitting down and thinking and coming up with different ways to solve something. Yeah. So these are just some of the skills, but I'll let Aaron and Li Sheng maybe add on if they notice any other skills or courses that are important as well.
Right. So I will continue from there. So I think it's similar to what Viknesh mentioned. So I think the core subjects at a PU level, definitely chemistry, physics, and maths. I think these are the subjects that you would want to have, moving on to chemical engineering, because these are the ones that are going to build your foundation. Because sciences in high school, I wouldn't say it's may not be sufficient. So it's good that you have these core subjects as part of your pre-U to prepare yourself for the chemical engineering program. maybe I can add on a little bit more about further mathematics. I think this is not a core subject, okay, but I actually did it for my pre-U A levels. What this subject has taught me is actually quite unique, okay. So like what Vignesh mentioned, problem solving, okay. Further mathematics was not my best subject, I can tell, I can say for sure, but bear in mind that this is a subject that, like I say, it's not critical, but it helps you to develop a unique way to look at problems. Because every time I look at a further math problem, it's like a high level kind of challenge, and it trains me to not give up when you see something difficult, and try to break it down into smaller pieces so you can solve things bit by bit. In the real world, eventually when you come into the real world, engineering is talking about large scale things. Okay, you're talking about building a whole entire plant, or an entire area, industrial area. So these are all large scale things. But do not panic. Please, just break down the problems into smaller parts and slowly solve it bit by bit, and find the right resources to put it in, so that eventually you will be able to manage the whole situation. And I feel this is a very unique experience, and I hope that if you have the capacity, you can try to incorporate further mathematics into your PU subjects as well.
Yeah, I would agree as well. I would agree
Yeah.
as well. In fact, further maths is actually a very good advantage, especially in engineering. Like like myself, I share the same thoughts with Aaron. I teach chemical engineering, so I can see the difference. When you take further maths, when students come in, they take further maths. There's a really strong advantage in that sense. So it's a really good point to consider as well.
Right. Yep. So I think I'll pass it on if Li Sheng has any maybe more to add in terms of the soft skills of like how to prepare yourself for engineering.
So I totally agree with the problem solving sides of things. We as an engineer, we always have given problems, not only by superior, by processes itself. You would always make an observations, and you would want to break down that simple observations into the why things is happening and how things is happening. You want to break down into those two categories, why and how. And you would always want to think about how I can tackle this problem. So a lot of the times is you are learning the facts in the chemistry or physics, and how to apply those facts into solving that single problem. According to some of the observations that you see, observations is a very critical thing is what you see is equals to what you learn, and how you use those learning into solving that problem. So converting, bringing that observations into problem solving. So when you make the observations, you need to communicate that observations to someone who has more technical knowledge than you, or who has been previously seeing the similar issues. So communication is how would you convey the observations that you see. So that communication soft skills is quite critical. In terms of, I totally agree with Aaron talking about further maths, because myself learning about I took further maths as well. Not just, you won't be utilizing all the complex mathematical equations in the university, but you would learn the soft skills from it. Is how would you break down some mechanical issues into some of the sizable chunk that you can solve by some other processes or some other observations that you see. You would bring them in. So those are the things that how would you tie different things together. Is at further maths will enable that skill set going forward from there. So I would pass back to Mr. Lucas to the next question, I assume.
Right.
Right.
Maybe Mr. Lucas, I can just a little bit more. I want to just share a bit. Because I also realized in when I'm doing engineering also, one of the critical things is also about analytical skills. Okay, because it's interesting to have the things happening around you, phenomenon and everything. But a core part of it when we want to talk about engineering is also how you analyze all these and translate them into useful data and figures and be able to present it in an organized manner, because you are dealing with a lot of things at the same time, a lot of observations, a lot of data and a lot of ideas, but you have to solve it in an organized manner, structured way. So you have to maybe try out certain things one by one, and also putting them into proper records, because all these documentations will also help you into, solving the big problems, because you want to build on your past experiences, or other people's past experiences, or maybe other people can build on your experiences, right? The things that you have did that is successful, or maybe, it didn't work out, but at least people have seen what you have tried, and then people can use other methods to further improve on your processes. And science and engineering is always forward looking, so it's about how to reinvent new things, new methods, challenge the old sayings, and always move into the future. So it's always ever changing, and this is something that you have to be interested about. I mean, if you really want to be good in engineering. So if this ticks you, gives you that motivation, I feel you are already on the right path. Yeah,
Yes,
to choose the
exactly.
engineering path.
This is the point that I was going to add on as well. This, what we are saying here is not what you should have before you enter the program. This is stuff that you will be molding yourself towards. And if you see yourself to be someone that, that has all the skills later on after you graduate with a chemical engineering degree, then this is the right course for you. If you see yourself, you want to be a critical thinker, you want to analyze stuff, you want to solve problems, you want to look at new ways to come up with something, just like what Li Sheng and Aaron has mentioned, then this is the right course for you. So
Right.
let's not confuse that. We are not saying that this is something you should have, because you all are in pre-U, so we don't expect so much of these things to be there at the pre-U level, but you should have an interest in these areas. If these are areas of work or areas of areas of of careers that you're looking into, then these are the things that you will be spending your time practicing. And if this interests you, this is the right place for you. Yeah.
Yeah, sorry, that was my son just now. All right, from what I gather from all of you, right, what students need to have is like, I think they need very strong problem solving skills, right? And they also need to have very strong maths background, right, to actually do this particular course, right? So that's what I gather from you guys. Correct me if I'm wrong, right?
Right.
Well, strong is a very subjective term. I guess it's more like the interest. I think that's more important. I think the interest is more important there.
Okay, you must
As
be
long as you have
passionate
the
about the
passion,
course.
yeah, you must be passionate and interested to solve those problems. In terms of how much strength you have in those areas, it differs, because we could have students who are generally average for their maths, but they like solving problems, and that doesn't really tell much, so as long as you have that passion in this area, you see yourself doing stuff like this, then this is the right thing. You're already at the first step, you've already gotten the first step out of the window, so I think that's the key element here lah.
Right, you can slowly develop all these soft skills as you go along the uni pre-U courses, the university degree, or even in your working life, you will continue to develop all these skills. But like what Viknesh says and Mr. Lucas, it's the interest has to be there, and then you're on the right direction.
Right. All right. So yeah, good. Something that can be trained up. Now. So don't worry, guys. So for those who are listening in, so as long as you have passion to do this particular course and you're the type of person who likes to solve problems, this will be the course for you. This will be the course for you, right? So things like if you, let's say, having a little bit of problems with maths, but you're willing to work towards it, you're still going to be able to do this particular course. Just put up, the effort for it. As long as you are, passionate about the things you do, nothing is going to be impossible, right?
Yes.
Okay, so let's move on.
Sorry, Mr. Lucas, just one more thing to add on. One more thing to add on that just came on top of my head. If students have interest in, environmental conservation, sustainability, now we talk about sustainable development goals from the United Nations, right? So a lot of these practices or a lot of these goals involve a lot of engineering, like providing clean water, affordable energy, looking at saving the environment, reducing emissions, reducing pollution. Actually, chemical engineers are a big, part of this, this goal, So if students, if you're listening in and you have interest or passion in these areas, this is also a good chance for you to explore chemical engineering, because a lot of chemical engineers work in these areas. We'll talk about it in more detail shortly, but just want to put this out there because it's talking about interest and passion, right? Yeah.
Good to know. Good to know that, Viknesh. All right. So let's look at the study duration. It's a 4-year course, right? Is it a 4-year course to complete the chemical engineering course, right? So how's it like studying the 4 years? Is it any different between the first year, second year, third year, and fourth year, right? Is there any challenging years for you guys, and is there any particular interesting years of that particular entire course, the whole duration of the 4 years? Can you share a little bit on that with us?
Maybe you can start with Lisheng.
Nisheng?
Yeah, so yes, I'll go first. The course that I've taken is MEng, specifically full name is called Masters in Engineering. So we have two types of engineering degree. We have Bachelors of Engineering, you have Masters of Engineering. Bachelors of Engineering normally take 3 years. Master of Engineering, you would add on another year to take on the 4 years. But me specifically, I took the 5th year because I have add-on or optionally chosen to go for an industrial year, which gone into the 5th year of the whole degree. So let's break down into what bachelor's and master's and industrial year, what are the differences in that? So the bachelor's and the master's for first to the 3rd year, they will all mostly share the same modules. They will learn about the same basics of chemical engineering. The first year, you will learn a lot about the physical chemistry sides of things. You will learn about the how to evaluate the chemical properties or the physical properties of some of the very well-known the chemistry side of things. And you would learn a lot about math and how this heat transfer works on. For example, you are cooking on a stove, you lit up a fire, how would that translate into cooking into a food? So that was the very basic of heat transfer. In terms of mass transfer, we would learn a lot about that as well. For example, how would you as the observation I always say is, how would you see a river flows within a river? How would water flows, and how would a honey flow a different? How would a toothpaste flow differently? And how would a rock roll down on a slope slightly different ways? So we're looking into aspects of how gases, solids, and liquid flow on the first 3 years on all those transfer phenomena. And for the master's year, the final year, you would have additional 2 more specialty modules. One of it is the research projects that you would do, and one of it will be the massive design projects which you do in a team. So in terms of the research project, you can choose which topics that you would interested in. As Viknesh was saying, that you have energies, you have catalysts, you have all types of new materials. So all those things are optional that will be available. So let's say 100 topics out there for 70 students to choose. Each of them will have their specialized tutor or lecturers who have years of experience too in that specific field that would give you advice. In terms of the design project for the final year, what you would do is you would have a group of, let's say, 8 or 10 students being given a specific task to design processes. For example, the one that I've been working, that I had on my final year, was to design a methanol production plant, which is specifically one of the bulk commodity. So you would look and specialize on making some of the unit processes, not just looking at the whole plant, but each of the processes, how would you convert some of the raw materials into the downstream processes, and one of your course mate will pick up your outputs into becoming his inputs to some of his processes. So that's mostly about the 4th year. For me, myself, I have additional 1 more year, which is specifically at the industrial placement. The reason that I've chosen this industrial year is what I want to do is to expand my knowledge or industrial experience, if you would say directly, before I step out to the career, before I step out to the real world. Because in 1st to the 3 years, you would experience all of the lectures, all of the academics. How would you translate those knowledge into solving a problem in the real world? We are talking about real world issues. We have a lot of the problems that we want to look at. How would you gain those knowledge or experience? So the industrial years fits into the gap of filling up the soft skills that you would want to develop. How would you convey a messages? How would you do a presentation? How would you convey an idea or convince the other that what your observations are seeing, and how you would use that project sort of learning into conveying into a real world issue. So that has grown hugely. Myself and a lot of my course mates have learned a lot in the industrial year, and then we will come back to finish off the master's year. So the sandwich or industrial year would be on the 4th year, and then the master's year will be on the final year, 5th year. So my course is slightly different from the traditional 4-year structures.
All right, so this is based on the UK system and also the 5-year program. I like the industrial attachment year. I think actually it will benefit students a lot, getting them ready to the actual world. I think you benefited massively from that particular year too, right? That's why you went for it.
Yes, that's one of the reasons that I see the benefits of it. You would spend a year longer in uni, but the experience that you would get, because you can build on the support from the uni that they have in terms of the relationship that the uni have with the industry. They will build on to every year they would have, let's say, 1 or 2 students that gone in. You can build on to the previous students, let's say 3 to 4 batches of previous students' experience that you can gain from reading their academic report that they have submitted. So you can gain experience through that side of things. Or you could get attached to someone who has been know how to train students to be an engineer. So they have always an attachment to someone who has been years of experience, let's say 10 years of experience, who has been training different students for 3 to 4 batches, and give them some of the real sense of belonging into giving them the actual project that they would handle, and gain some real sense of achievement at the end of the year. So that is a huge experience that I would say, even though if you're not gaining a full year of experience, I would still encourage students to go for, even if you have a summer break for every 3 months in the summer session, I would encourage students to actually go to look for an industrial experience. You have 1st year to 4th year, you have at least 3 to 4 summers that you can look for all those experience. Even though you're in the end of your 1st year, you may not have a lot of the engineering knowledge, but you would get exposed yourself to how people deal with issues and what are the specialty skills that they can develop, but not available in the uni or academic sense. So that is a hugely important key if you really go for industrial.
All right, thank you, Li Sheng. What about the setting in Malaysia? Viknesh, Aaron, you
Yeah, I think Vignesh can start first because mine will be a bit of a mini hybrid.
Yeah, exactly. And I'll extend further from Li Sheng's point earlier. So what Li Sheng was talking about is the UK system, all right, and it's slightly different as well. Like let me give a big background on the engineering programs, both locally in Malaysia and also overseas. So typically, engineering program is 4 years, okay? And they sometimes can be called in different names. So in Malaysia, local syllabus, we call it 4 years Bachelor in Engineering, all right? So we call it BEng in short, all right? In the UK, they have a 4-year program, but they call it MEng, Masters in Engineering. So it's an integrated program, all right? However, they also have a 3-year program because in the UK, based on the standards they have, 3 years is sufficient for a bachelor's. Yeah, but we have a lot of, but in terms of accreditation, 3 years is not sufficient. They have to do the 4 years. All right. So that's why a lot of people opt for the 4 years. And of course, they get the name called as Masters in Engineering or MEng, right? So these are the fundamental differences. So we do see local institutes that offer chemical engineering, but they have a 4-year degree and they're called Bachelors of Engineering. But if you go to UK, it's 4 years as well, but it's a MEng. All right. This is assuming that you want full accreditation because this has some impact on your registration as an engineer when you start working, right? So that's why it's very important to look for 4-year degree programs when it comes to engineering. Yeah. So this is the difference between the local scene and that. But if I want to make a distinction about what are the programs available, each university has their own unique way of arranging how the program looks like. All right. So, but at the end of the day, the skill set and the core subjects are the same. All right. Just a matter of when you take it, whether it's in your first year or your second year, and when you do your projects and things like that. So, also to answer the question posed by Mr. Lucas, which are the interesting parts and which are the challenging parts in the chemical engineering process. So when I was doing chemical engineering, for me, as mentioned by Sheng earlier, we spend most of our time doing the fundamentals of chemical engineering. This would typically range from year 1 to year 3. But depending on the university that you join or the program that you join, you have this thing called a design project. All right. So a design project can come either in your year 3 or your year 4, your final year, depending on which course you take at a certain university. So what is this design project? This design project combines all your core knowledge from the chemical engineering course from year 1 to year 3, and it applies into a project where you design a particular chemical plant or factory. And also you're working together with a group of people or group of classmates, all right? And you're putting together your knowledge and understanding and to try to figure out a particular plant that you want to design. So if you're given a task to design, like what Sheng mentioned, designing a methanol plant, methanol production plant. So you need to decide what are the raw materials, which equipment you're going to need, what's the energy consumption, what's the water usage, all sorts of things need to be factored in to come up with the design. And this project is about a year long, typically. Typically, it will be a year-long project. And that will be a very challenging one. So that was a challenging one I experienced when I was in the chemical engineering program. But it was a very fulfilling one as well, because whatever you learn in class, you do your assignments, you do your coursework, you do your examinations. But this design project encapsulated everything. Yeah, it applied everything that we learned. So that was a very cool thing as well. But interesting stuff would be like the research projects that we pick up in the final year. So in every university, whether be it in Malaysia or in any other country, usually the final you'll have some research project that you'll take up, and then can go with any of your passions. So if you like sustainability, or if you like reducing waste, you like managing waste, or you like to look into filters, or you like to look at heat exchangers. These are things that you can zoom in further in your final year research. And this to me was a very exciting portion as well when it came to the chemical engineering course. But just wanted to make that clear distinction in terms of what are the programs available. But Aaron, go ahead.
Right. Okay. So I think both Sheng and Viknesh have mentioned most of the part of the program, and also how about like design projects and research projects. So for me, maybe I can just share a little bit more. So myself, I did probably now it's maybe a unique program as well, because I did a 1+3 transfer program between Taylor's University and University of Birmingham in the UK. So I actually completed my first year in engineering locally in Taylor's. And after that, I moved on to University of Birmingham to continue my second, third, and fourth year, eventually getting the MEng degree and MN for my degree. So I would like to maybe focus a little bit more on the soft skills. Rather the program itself, I think they have been well presented. So personally for me, the soft skills that I think you can also take note when you are doing this program, part of it is for me was the challenging part was in my second year when I first went to UK, right? So it differ from person to person, but for me it was a very different experience when I first stepped into UK, since I was quite used to the whole Malaysian education system. So I was pretty much well taken care of. A lot of information was given quite helpfully, I guess, from your peers or your lecturers. It's just more, well, I don't like to use the word, but maybe I just use it like it's a kind of like spoon-fed program in Malaysia. Okay, but by no means I am discrediting any of the Malaysian system. But when I first went to UK, I was like shocked, because a lot of the people there do the learnings a bit differently. So they have a lot of self-learning involved. So the lecturers there don't just give everything to you. They guide you along. They encourage you to find them during your free time, and they want you to have the initiative to do things on your own, to find the solutions to the problems. They're always open, for you to come over, but they're just not going to serve everything on the plate to you. So that was the biggest culture shock that I had when I moved over. And it was a struggle, to be honest. It was a struggle, and I didn't really perform very well in my second year. But after adapting to it, I felt like it was it's a very big contribution to who I am today, because I think it challenges you to step out of your comfort zone. The program itself is incredible, but when you develop yourself personally over the 4 years, you would and sort of transform yourself. It's a very you feel a huge sense of fulfillment and achievement. Okay, and that's what I like. It's all about this engineering program, is that it not only gives you the challenges on the technical part, but it also tests you on your personal development. And I think it's a very critical part, because as you move along in your life, all these things that you experience in uni will build you into who you are in the future. So I think that's just the little bit extra that I feel like I want to add on. When you're talking about the program, don't see it as a dry program. It has a lot of character in it as well. So it's just that you yourself has to go and find that part of you, and make sure you don't hide away from it. Face it, overcome it, and you will be a better person overall. Right? I think that's what I wanted to say. Yeah.
I would like to add on something as well. As Aaron would say, that the transition between the culture is quite difficult. It's the same for me as well. I came to the UK on the first year, and I did experience the first hand of how would cultural shock really affect your grades. But you, as a student, you will always want to learn more. So the mentality of learning and push forward to gain the support that you can. The support can comes from the lecturer that you can ask for questions. If you have done some homework, if you have done some questions that you're stuck with, just bring it up to the lecturer at the end of the lecture. So just show them what you have done. They might have able to show you some of the issues that you have made, or some of the mistakes you have made. They will guide you down the right path, or they would show you which of the material or reading material that you can get. Most of the reading material is available in the library. You just have to look for it. So the looking or searching for information part of it is hugely missing in the Malaysian education culture. So searching for information is a huge thing. You need to look for the keywords that you want to look for, and what sort of information is suitable for your level, and not too advanced that would convolute into yours. You would somehow spiral into a rabbit hole that you would never find the right information. So always find the suitable level of information, the key information that you want. That is the learning. As a uni student, you would have to adapt very quickly in terms of changing how we learn. always do some preparation work, always prepare and do some of the coursework, and you can really get a lot of a sense of what the exams would actually look like. A lot of the questions will build on a lot around that, and if you search enough, if you look enough on the supporting material as a suggested reading material list, you would learn a lot more than some of the just the lecture notes. So use the support structures that you have, use the support system, even ask for the seniors for some of the advice that they have gone through. Yeah, use all the available resources you have available to you.
All right, I can add on as well. I think there's a few points I'd like to highlight here in addition to that. Well, whether studying overseas or whether studying locally, we must put out a major point here. I would like to highlight that it depends on you as the individual. So you have to see who you are, right? So like when we have students listening in right now, my advice would be to know yourself a little bit better and decide, are you the type that adapts easily when you go into different cultures? And if you're not, that's okay. That's completely fine. You're not any lesser than compared to those who are going overseas. And likewise, on the flip side, if you would like to go overseas and experience new cultures in a way of doing things, then of course going overseas to study is very much welcome. So it depends on your interest and your personality. We have a lot of students that prefer being at home focusing on the studies, but we also have some students that prefer to, but at the same time, go work overseas afterwards. That's completely fine. But we also have students that want to study overseas and come back, to bring that experience back to Malaysia as well. So that's also an option. But some also would like to continue working over there, like Li Sheng himself, Yeah. But one thing I would like to disagree, though, I think in terms of university degrees, particularly in chemical engineering, even the Malaysian programs also guide students. We don't really spoon feed. I think the only difference here is more of the culture of guiding. Maybe there's a different style of guiding. So if I were to do a sort of comparison, it's a matter of like how you learn, the style of learning in a different country. That's one. And the style of guiding is very different. So I think people need to get accustomed to that local way of guiding, and from there building your knowledge on that front. So maybe a slight small little thing that I would like to point out over there. But I think aside from that, pretty much agree with everything that's mentioned as well. Yep.
Sounds like a very wholesome program from what I gather from all three of you. Because
Right.
you guys don't just learn the subjects in chemical engineering. You develop your problem solving skill, you develop your analytical thinking skills. There is also creative thinking skills, I believe, also, right? And of course, on top of that, you do group work, teamwork, communication skills, leadership skills. Wow.
Yep.
What kind of graduate are we developing there? Everyone, all employers will be grabbing all chemical engineers graduates, right?
Exactly. Yeah. And in fact,
Right.
I think this is a good point relating to what Aaron mentioned earlier. He said the program is not dry, it's actually got character. Let me expand on that. Exactly from what you said, Mr. Lucas, I'll explain further. Chemical engineers need to look at things from the commercial standpoint. They need to look at how feasible their design or their decisions are going to be. They need to justify things, they need to present things clearly. They have to look at different options. That's why the problem solving skills are very important here. You have to look at different options. I want to go with equipment A or equipment B, which is going to be better. I need to design an equipment. When I design it in a certain way, why is this better than the rest? We have to justify. We have to look at it from a commercial standpoint. I believe Aaron, who's in that line of work, he can tell us very nicely
sure.
about how important that is. So I leave that to him. But in terms of the technical portions, like, is this going to impact the environment? Is this going to pollute the environment? Is this going to impact the safety of the workers and also the surrounding people? You're going to be building a plant somewhere, not in space, it's going to be on the ground somewhere. And it might affect certain people living in that area. So these kind of things have to be factored in. So
Right.
when you look at all this, that's where I completely agree with the point that Mr. Lucas mentioned, that chemical engineers essentially are the full package. They cover so many things, and a lot of employers would like to hire chemical engineers because there are so many different things that they can do and they can cover as well. So Aaron, over to you. Take it away.
Yeah.
Commercial.
So yeah, I think that I can explain a little bit of it, but also I mean we're just providing a sneak peek because I'm sure we're gonna talk a lot more about the career options that you have if you go through a chemical engineering degree. But just a little bit about the commercial side or in the industrial world. You see, when designing something, there's so many things involved. You just have to find the right balance. It can be like for my current work. It's always the balance of performance, the economical costs, and also the feasibility of the land space that you're occupying, also the footprint. All these are bits and pieces of finding the right equipment and using it at the right place. Things may work here, but in a four-season country, perhaps you may need a different design, a different insulation, or different environment altogether. So there's so many factors that plays a part. So when you do all this, that helps you to build your real overall thinking and how you look at things. You look at the things from big picture. Look at things when you zoom in to the detail part of it. So you have to constantly like zoom in, zoom out to find the right balance with all your stakeholders. And I find that chemical engineering program, when you go through it, it does develop you in that way, because for me, it's always more about the life part of it, because I'm not like a top student, but I guess it helps to develop you as a person as well. So that for me is the most essential part of doing this program. I would encourage people who wants to discover themselves or like have interest in it to just go for it. Slowly find yourself, and yeah, you'll be fine. We will talk more about the career options later, I guess. Yep. Passing back to Mr. Lucas.
All right. Okay. So yeah, we heard so many good stuff about chemical engineering. Let's hope our listeners are actually getting all excited about this course too. Yeah. All right. So next, okay, let's talk about locally in Malaysia, right? So there are a lot of university offering this particular course, right? And I'm sure in the future there are more which will actually come up, right? So how does the student actually know whether the chemical engineering course they're applying to is actually how to say accepted or certified or accredited by the engineers board? How do they know whether the cert they're actually getting is actually not a fluke?
Okay.
Viknesh?
So maybe I can step in for that. All right. So number one, the first criteria is look for 4-year engineering programs, especially when it comes to Malaysia. Look for 4-year engineering programs. Okay. So even if you want to study overseas and you want to come back and work, the magic number is 4. So I'm just going to leave this here at 4. That's the magic number. All right. Secondly, when you go and inquire about programs in different universities, the first thing you can ask is this accredited by the Board of Engineers Malaysia? All right. So this is a very important part. Usually, if they are able to run the program, they already have some initial prior preliminary certification done. All right. But here's the thing, I'm going to break this down a little bit. If they've already had graduates that have come out from the university, they should be able to have accreditation from the board. All right. So which means that the moment you graduate with that degree, regardless of which university, you are able to register with the board as a graduate engineer. So that's when you can start practicing as an engineer and accumulating experience and eventually further your professional experience further. Okay. That is assuming that a university already has the accreditation, and you can just see based on the serial number that they have. When normally they advertise or when they share with you a chemical engineering program or any engineering program for the matter, there will be a serial number at their brochure or their booklet or something like that. If they don't have it, you can just ask for it, right? Which they should have. That gives you a assurance that it's already accredited. However, there's another alternative here. This is where if the university just started the program, all right, so, and you are probably one of the first few batches, right? So don't panic, okay? Don't worry. Usually that is the process of accreditation, which means that the first batch needs to graduate. And when the first batch graduates, they will automatically start filing for accreditation. And they will use the information that has been gathered from your first year until your 4th year to complete the accreditation process, right? So then that would usually take about, I don't know, between a year to 6 months, 6 months to a year, depending on the situation. But as soon as the accreditation is done, your university will get in touch with you and let you know. Even though you've graduated, they'll let you know. They'll say, "Hey, Aaron, you're one of our alumni. Just to let you know, we have successfully got our accreditation according to process. You can now easily register with the Board of Engineers. So and then you can easily do it without any issues. So these are the two alternatives. Okay. So the first one is if the accreditation is already there because the university has been running the program for quite a number of years. So they have graduates already out and there won't be any issue. The second alternative is if the university is new or the program is new and the first batch just graduated. So that's part of the process. So usually if the university is not doing anything illegal, you should be fine. So don't worry about that. Okay. Yeah. So that's how the students can know whether, what is that? The program is accredited or not. Yeah.
Right. Thank you. Thank you, Manish. All right. Wow. So much information already on this particular podcast session. I feel that you guys are very dynamic today, right? You shared a lot of information pertaining the course, and there's still one important part that we have not spoken about: career options. After you graduate, what does it entails for graduates out there? And I think we'll save this for the next episode, right? So for the first time ever, we actually have a career talk. We have a second episode for this chemical engineering course. So guys, if you are listening out there, you want to find out more about the career options about chemical engineering, please click up there, right, in the link right above. Or later, I will actually give you a link over there. You can actually click on this link over there and just move on and look at the second episode whereby we're speaking about the career options in this particular field. Right. So again, thank you very much, Viknesh, Aaron, and Sheng, right, for today's session. Right. We'll speak to you again about the career options on engineering, on chemical engineering to be specific, on the second episode. Right. So yeah, don't forget to subscribe and drop your like for this particular video if you have actually found it useful, especially that all three of them have given you so much information about chemical engineering. So if you're looking into it, yeah, this would be the place. This would be, I think, further affirming your choice for the course. So thank you very much. I will see you in the next one. Bye. See you.
Thank you.